Going to go over how to do a hypothesis test for one sample proportions. So first off, our problem is Harris Health Systems says that 87% of their employees get a flu shot every year. A sample of 300 employees found that 249 said that they received their flu shot in the last year. We want to test this with an hypothesis test. Assume that the level of significance is 0.01. So because we see this percentage here and we see 249 out of 300, we know it's going to be a proportion. So we're going to use a one sample z-test for proportions. So we only have one sample for proportion, so one sample z-test. So the first thing we're going to do is write down our null and our alternative. So the claim here is that 87% of the employees get a flu shot every year. So the claim is that our proportion is 0.87. So because our null is always equals, that means the null is going to be proportion equals 0.87. And this one doesn't give us a direction of greater than or less than, so we are just going to do both directions with the not equal. So this is our null and our alternative. So next part, we need to check our conditions. So the first one is n times p is greater than or equal to 10. So our n, there was 300. We just said our p was 0.87. So what we're going to do is we're going to multiply that and get our number to see if it's greater than 10. And then we'll do the same thing with n 300 times 1 minus 0.87. And if you calculate those out, they are both going to be greater than 10. So we're good with that one. The next one we have random samples. This one said they sampled their health systems. We're going to assume that that one was random. And then the next one is 10% of the population size. 300. There's probably a lot of people in the health system, so that would make sense that it's less than 10% of the population size. So now that we passed our assumptions, we're going to go ahead and run our test. So if we go into the inference for population proportion, we want to go into our number of successes, and then we're going to put in our sample size, which is 300, our number of successes, which was 249. And this time, instead of confidence interval, we are doing a significance test. And the null p-value, let me spread it out so you can see this better, is 0.87. And you can see there's our options here for the alternative. This one is two-sided whenever you have the not equal sign. And you can see it shows up right here. It should match what you've written down. So our null p equals 0.87. Our alternative p does not equals 0.87, which lines up. It gives us our test statistic. So our test statistic is negative 2.0601. Then our p-value it gives us in the next spot. So p equals 0.0394. And we need to compare this into our test here. So we're going to compare it to the level of significance. Level of significance alpha equals 0.01. 0.0394 is greater than 0.01. So we are going to fail to reject. So p is greater than alpha, so we fail to reject the null. This means we do not have convincing evidence for the alternative. which means we do not have convincing evidence that the proportion of employees who get a flu shot every year is different from 0.87. So we don't have evidence for this alternative. That means their claim can be true, right? We don't have any evidence against it. So you can look over at this decision button if you want to. So our significance level was at 1%. So you can change it into 1% if you want to try out that decision button. And you can see that these values here will show you where the rejection region is based on your t-value. And then the p-value will be listed here. So when you're doing these, make sure write out your null and alternative first. Then once you put all your information in, it'll give you your test statistic and your p-value. P-value is greater than our alpha level, so we fail to reject a null. There's not evidence for the alternative. Now, if our alpha was 0.05 instead, so say our alpha equals 0.05, then 0.0394 is less than 0.05, so we would reject the null, and we would have evidence that our proportion is different from that 0.87. So that is how you do hypothesis tests for proportions with a one sample z-test using the DCMP app.